All right, we're back talking logic and reasoning. We're going to move into the next section, which is 2.5, and it is about axioms and postulates. And this is going to be a pretty quick one. Okay, axioms and postulates are just fancy words for rules or facts. So we're going to say an axiom or a postulate is a statement that is accepted without proof. Is a statement that is accepted without proof. Okay, I don't want to go so far as to say that they're common sense because some of them are, kind of complicated ideas, and I don't want to say that, it's common sense, you should know that, because you shouldn't. But there's 5 of them that we're going to write down today, and I hope that you'll see that they really don't require any proof for you to accept them. They make sense. So we're going to write down the first one. The first one says, through any 2 points, there is exactly 1 line. So through any 2 points, there is exactly 1 line. So hopefully that looks like a 1. 1 line. And we'll draw a quick example of that. I'm going to try to. We'll see how it goes. So here is point A. And here is point B. And my postulate or my axiom says that if I draw a line through point A and point B, well, that's it. There's the only line I can draw that goes through both of those like that. If I try to draw another line through A, that's fine, I can, but it's not going to go through B. And so it seems, that's what I mean when I say it seems kind of like common sense. It's not real hard. But you need to remember them because they do have a place later in our geometry, and you need to be able to recall these. And I say, why is this true? And you can say, well, because through any 2 points, there's exactly 1 line. And I'll say, oh, that's right, you're so smart. So number 2, through any 3 non-collinear points, through any 3 non-collinear points, there is exactly 1 plane. Okay, and the word exactly is a powerful word because that means there's no circumstance ever where this won't be true, right? It means exactly 1. So we're going to attempt to draw a picture of what that looks like. It's going to be a challenging picture, but we are going to give it a try anyways. So we're going to start with 2 points, A and B. Now, these 2 points we could draw a line through, and they would be collinear. But if we add a 3rd point out here that's not, point C, there's our 3 non-collinear points. And it says that through any 3 non-collinear points, there's exactly 1 plane. Well, you could say that the plane of this notepad I'm writing on, the flat surface you're writing your notes on, that's the plane that A, B, and C exist in. What we're going to try to draw is a plane that goes through A and B, but it doesn't go through C. And so I'm going to start with the flat surface that I'm writing on now. So here we go. This is our visual representation of the flat surface that I'm writing on. I'm kind of marking it off as a little space. Now I want to show that I can draw another plane that goes through A and B, but it can't go through C also. And the way I'm going to try to illustrate that is to try to make this into a little bit of a 3D drawing. We'll see how it goes though. Things like this are pretty tough to draw, but if you can, it really helps when you're trying to visualize them. Okay, so what I'm hoping that you can see here is this idea of having this red plane, which is the paper you're writing on, and taking this other blue plane, which is maybe another piece of paper, and trying to stand it up on your A and your B and have it pass through them and come out the other side. All right, so number 3 says that if 2 points lie on a plane, then the line containing those points lies on the plane. Okay, so that says if we have a plane, again, our note paper, flat surface, and in that plane there are 2 points, A and B. Our postulate here says that the line that contains those 2 points also lies in that same plane. All right, number 4, almost done, hang in there. If 2 lines intersect, then their intersection is exactly 1 point. So that's probably the easiest one to draw. 2 lines, if they intersect, their intersection is exactly 1 point right there. Not bad. And now we're on to our last one. Remember, these are facts. These are things that we're just accepting are true, drawing a little picture to indicate what we're talking about, but we're not going into a lot of detail trying to really justify them. We're just accepting these things are true. So number 5, if 2 planes intersect, and this is a tough picture. If 2 planes intersect, then their intersection is a line. I want you to think about the corner of a room. Maybe the corner of the room you're in right now. When you look in that corner, it probably looks something like this. Right? So what I want you to imagine is that these walls extended past each other. I know this isn't ideal, it's not great. It should look like you know, 2 pieces of paper if you cut a slit in them and you stuck them together, or the corner of a room if you could be on all sides of the wall and see all sides of it. But the idea is that where these 2 planes intersect, the only thing there is going to be a line like this. And remember, my planes, I'm drawing them as rectangles so we can see them. They really go up and out in every direction. So they don't end, they extend forever. So that's how you would draw that. 2 planes intersecting, then their intersection is a line. So those are our postulates and axioms we're going to work with. Study those, make sure you can regurgitate them quickly. There's not much to them. They're pretty common sense. See you later.